We'll just do it live. Okay. All right. So quadratic equation solutions. It's okay. So we're still in quadratics. Quadratics. Okay. And now we're in the subcat because we discussed. What did we discuss so far on quadratic? We discussed vertex form, standard form. Okay. But then there's also intercept form, which is another one of the types that we have. So just give me a second. I'll pause in a second. Get it. So quadratics, and we're going to be dealing with solutions to quadratics. Okay, solutions. So what does it mean to be a solution to a quadratic? What does that term mean? It means well, it's actually just means the x-intercept. So imagine a quadratic, and it looks like this, whatever. That's a solution, right where it crosses the x-axis, okay? So these are considered solutions of a quadratic. And for the next week or so, we're going to be discussing ways to find the solutions to a quadratic. So far, what we know in the past is if we have a quadratic equation, if it's given to us or whatever, drawn out, we can find, let's use a different example here. We can find the axis of symmetry, we can find the vertex, we can find the y-intercept, we can find some of those things. So y-intercept, vertex, axis of symmetry, none of those have to deal with the x-axis. So now we're actually taking a look at where it does cross the x-axis. So now you can plot even more points. You can get an even clearer picture of what the quadratic looks like. Okay, so let me pause for a second. All right, so let's look at an example. Let's use the graphing calculators for this. So the example is f of x equals x squared, what is it, plus 2x minus 3? Yeah, plus 2x minus 3. All right, the very first thing I wanted to do is put that into your graphing calculator. Yeah, let's start with that. Just put it in your graphing calculator. This shouldn't be too bad. Okay? And now how are you going to find, after you put it in your graphing calculator, how are you going to find the x-intercepts? ABC, not quite ABC. Well, let me tell you this. Do you guys know how to do the thing where you look at your graph and you trace along it, or table of values? Yeah. Maybe table of values would help. So put it in your graphing calculator, put it as a function, x squared plus 2x minus 3. Okay, and then hit graph. And so let's see if I can actually show this on my... Okay, there you go. There's a graph of it. Awesome. All right, so we're going to go to the table. All right, the table. I'm showing this in the video so you guys can watch it later. But second graph is the table. And then we have a table of values. Are we all at the table of values? Yeah, what's up?
I put the same thing in, but it doesn't look like that on my graph.
Let me see. X squared, because you don't have it in right. X squared plus 2x minus 3. You have it times 2x. Okay?
Oh.
Do we all get the graph of what looks like a parabola on our graphing calculators? Do you see how those that don't have the graphing calculators are now missing out on a crucial part of the lesson? Yes. Okay. If I have a quiz this week some point, hey, get out your graphing calculators, graph this crazy function, then draw it for me. Guess who's getting hundreds? Everyone has a graphing calculator. Guess who's getting zeros? Everyone who doesn't. Okay. So super simple, just quiz on graphing calculator. All right. Anyway, second graph to get to the table. We have a table of values, right? Now, what do we notice about x-intercepts? Here, there's 2 of them, or here, there's 2 more. Is there anything you can tell me about an x-intercept? Lucille? The y value is 0, which is crucial for looking into your table of values to find it. So why don't you go through your table of values and find where y is equal to 0. I found one of them. And there should be, well, we'll discuss this. There could be 1, 2, or 0 solutions, depending. Because your quadratic could be like this, in which case there's no solutions, no x-intercepts, no solutions. All right. I might use the word solution or x-intercept interchangeably. It's also called, I'll get into the other terminology they might use for that. So did we find any x-intercepts for this equation? I found one over there, which makes sense. Oh, I found, yeah, wait, no, that's one of them. Y has to be 0. Remember, your y is 0 here. Y is equal to 0 at x-intercepts. At x-intercepts, y is equal to 0. All right, I found one of them. It's at -3, 0. That's one. For this equation here, here's an example. So for this example, that's one of our solutions. What's the other one?
1.
1?
1, 0.
Ah, 1, 0. Very nice. Yeah, okay. So now if I'm graphing this, let's erase the example I put up here. All right, if I'm actually going to graph this function, I know that -3, 0, 1, 2, 3, that's a point on the graph. I know that 1, 0 is also a point on the graph. Does this open upward or downward?
Downward.
Oh shoot, this helps Dom. Nothing, Dom, don't pay attention to us. We're doing nothing over here. Ronan, what's up? Yeah. So hopefully you know based off this value here, if it opens upward or downward. Dom, I really should send you to another classroom. I have to see how this lesson goes, but you continue. You keep working over there. Okay? So now, whatever else is, I'm not going to talk about the other things we already discussed, but we know the x-intercepts here and here, meaning it looks something like this or something like that. Those are your two options. Just ignore everything else. Obviously, you will know which one of these it is because you just took a test on it. So you know if it opens up or down. You know what the y-intercept will be. You know the axis of symmetry. You know all that good stuff. You know the vertex. Okay? You can still find the vertex for this. These are just x-intercepts here. But that's the whole process. All right? For finding the solutions by graphing. All right. So I'm going to pause the lesson there for now. I'm going to ask you guys to work on a worksheet that involves doing this, taking an equation, graphing it, and finding where the x-intercepts are. That's called finding the solutions by graphing. Okay, there's more to today's lesson, but that's it for now.